Good morning, everyone. I want to start this presentation with asking a few questions. How many here is working with data streams? Could you raise your hands? There's a few people. How many people here have heard about the CDC, Change Data Capture? That is also a few. That's good. Okay. Do any of you, have you ever used CDC before? One guy? Two? Okay, excellent. You will learn a lot. Okay, so I will start with myself. I have 20 years of experience as a software developer. Currently, I'm a founder of a new startup here in Stavanger, where we are working with data. And previously, I was also the founder of Boost AI, which is the famous chat bot company that was founded 9 years ago. So, what is Change Data Capture? It is basically a architecture that enables functionality that can track changes in a database. So every time someone inserts something, updates something, deletes something, it creates an event. And this event can be pushed into other systems. So Change Data Capture is a valuable architecture or technology to capture data from one system and move it to another system, do data replication, and yeah. Most of the common databases support Change Data Capture. Even SAP supports it. And one database I have not mentioned here is Neo4j, graph data, but that's only supported in the enterprise edition of that. Most databases have supported this for about 10 years now. So everyone who has upgraded their database lately should have that functionality available in their existing database. The exception is Oracle. You need additional license. There's a lot of use cases and business value in using Change Data Capture. Real-time analytics and business intelligence. You just get up-to-date data immediately into your reports. You can replicate data. You get data synchronization across all different systems. And one of the fun things I've done earlier is that we have a legacy system. We need data from it. And we can they don't have an API for data extraction or something, and we are like, we need data as quick as possible into our system, so how are we going to do that? So since most legacy system runs on either Oracle or SQL Server or IBM DB2 or something, we can use Change Data Capture, do the changes in the user interface, and see what events are getting produced, and then capture the data we need. So I've done that a few times for some older systems. So it means that legacy systems can also support new digitalization strategies of the business. Another good use case is you can start building diverse data sets by joining multiple data sources. And it also helps you to build, for example, if you want to build training data, that can also accelerate data scientists, and yeah. And the last one is a hot topic that is really hot today. And this is by keeping, there's a concept called ontology. I'm not going to go into details about it because that's a presentation by itself, but it's like a map of the business knowledge. And when you extract information from all these different data silos, data sources you have, you can also update the underlying ontology in your business. Yeah. So getting started with CDC and Microsoft SQL Server is actually very easy. This text is a little bit small at the moment, but yeah. So the first thing I actually do is checking the role of my user, and it needs to have, I think it was a sysadmin role or something. That's a requirement to get access to enable CDC. So you just need to check that. In the next step, I have actually two databases with multiple tables. So you basically just enable CDC on the database first. You create the table, and then you enable CDC on the table. That's it. Now you have enabled change data capture and Microsoft SQL Server. I do the same thing for the other database, enable it, the functionality on the database, create the tables, and also enable the change data capture from the tables. You don't have to go into details of it. Everything is also in GitHub if you want to explore it afterwards. But it's really simple to get started with Microsoft SQL Server. So the next step is Kafka. Kafka is like this middleman in your architecture that processes all these events. You can call it a message system, a storage system, or a stream processing engine. It can do everything. It's an amazing technology. There are also other great alternatives to Kafka. My favorite is actually Apache Pulsar, which is very similar to Kafka, but it handles things a little bit better, in my opinion. Yeah. So the story behind Kafka is a similar story I was involved with a few years ago at Aker BP. A chaos of data silos and a lot of brittle, custom, point-to-point pipelines. So Aker BP created a unified architecture using Cognite. And LinkedIn, they used Kafka. Cognite and Kafka is not exactly the same thing, but the idea is the same, a single unified data platform. So Kafka, the advantage to start using Kafka is that you can now eliminate custom plumbing. Engineers can easily connect, they reduce integration complexity, and yeah, it makes things a lot easier and smoother, and the code you write will be like 10 times less than doing everything by yourself. It's also a lot more reliable when it comes to using data schemas. You can standardize data contracts between systems, and that will prevent a lot of dumb mistakes. And you also get data reusability. And this is actually a huge advantage because in an organization, you can have different teams that want to use the same data. So since Kafka has this publish subscribe model, it basically means that, oh, I want to publish some news about finance, and you can have multiple teams being subscribers to that topic. So you can create multiple topics, which is the concept of creating a title for the kind of messages you want to provide. And by that, multiple applications, consumers can have different subscriptions and consume message in their own pace, which means that if someone is slow at consuming data, they never get out of date because they have their own subscription and can receive message at a pace that that system can handle. It's also sequential and ordered and takes care of a lot of things when it comes to messaging of events or messages, or what do you call it. Getting started with Kafka is a lot easier than many people think. So I'm going to start with the basics. We're going to download Kafka. You just go to the website, find the binary download. I have a server here running Alma Linux, which is the same thing as Red Hat Linux, Red Hat Enterprise Linux. Yeah, for those who are familiar with Linux, you can just download it and extract it in one go. And it's installed. Now we need to configure it. This is just some basic configuration you have to do to set up a new Kafka instance. It needs a cluster ID, and you also need to format the partition that you're going to store messages on. But that is done really quickly. And then you should basically be ready to go. So that's the random ID that's generated, and all this documentation, this is a copy-paste from the documentation on the Kafka website. So it's nothing more fancy than that. And you don't need to jump on creating a distributed Kafka system on your first try. A standalone is plenty. So everything is done, and now you just need to start Kafka. And basically, you're now running Kafka on this server, quick and dirty. The defaults in the configuration is good enough. You may have to change the listener IP address if you want to connect from a remote machine. Here I basically create the topics. You want to subscribe for data points. I've also created topics for work permits, which can be interesting if you want to join this. We also need assets. And the last one is, you don't need to do it like I've done it, but I need a link between assets and work permits, so I know which assets belongs to a work permit. So that's basically an introduction to Kafka. The next part we need is something to connect SQL Server with Kafka, and that is Debezium. So the explanation on the website is super simple. It's an open source distributed platform for change data capture. We pointed out at our database and our Kafka, and it will start moving all the CDC events into Kafka. So, there's really nothing more to explain about Kafka. It's better just to start using it and read documentation and explaining that much more. So I start the same process here. We download the Debezium. The website can be, it's not the best website to find the correct binary, but this we can show where you find this Microsoft SQL Server plugin. We need to create a plugins folder. And then we need to move or download and extract this plugin into that folder. And now it's installed. Just to be sure, I just restart Kafka. I don't think you have to do it, but I do it anyway. Yeah, so the next part now is configuring Debezium. So I have two property files. You need a unique name, that you see on the top there. You need to add the database details. You need to map which tables you're going to extract data from. You have some transform functionality, which topics you're going to route the messages to. This is just using a regular expression that just takes the database name. And at the last step, we need to handle the decimal value. That's an edge case, so we just convert it to a double in this case. In this case, it's fine. So, but you could also convert it to a string if you need better precision. This is the other database, another unique name. Yeah, do basically the same thing. We have more tables. We are now work permit asset, permit asset. We have two transformations. The reason for that is that we have in work permit we have a dash or an underscore in SQL Server, and we just convert it to a dash. And we also have a post processor in the and that's handling inside work permit. There's a generated column that generates value every time you insert something. So we need to do some post-processing to capture it. So it can handle advanced use cases also. Yeah, just making sure the plugin's path is correct when we start this Debezium plugin. And now we basically are starting Debezium on Kafka. It's so we just refer the different configuration files. You need Kafka Connect properties files, and you need the two database property files. And that's it. So now, everything is working, and when you insert data into SQL Server, it will be captured and inserted into Kafka. So the next process now is to read this data from Kafka. So I've created a small Rust application here. I'm in love with Rust these days. It connects to Kafka, and it reads the data, and it also joins the data so it can show some messages. So I created the data structs here for the different objects. There's the topics I'm going to subscribe for in Kafka. And now I just create the consumer. Simple as that. And then we start creating the loop where we have the consumer receiving the messages in the bottom. And the message you get from Debezium is there's a lot of data in it, a lot of metadata about the record and event. So I'm just now going into it. There's a block in the JSON that is our name payload and after, and there I capture the data that looks like how it looks in the database. So all this is available on GitHub, so you can take a look on it afterwards. So there's nothing more special I can mention. No. So soon I will run this, so you can see. Yeah, I don't know why I did it, but yeah. So yeah, I push the assets and do the joining in, like in a global list. So yeah. And the consumer commit messenger is important. It tells just Kafka that you have consumed the message, and it can move the pointer to the next message, basically. So we start with inserting data. We start by creating an asset, which is a pump. And it gets an ID, which is 8. Then we create a work permit. And at the bottom, we create the relation between the work permit and the asset. So we have that link. So while the Rust application is running now, in the background, all this will be consumed. So you will see I have received a new asset, it has received a work permit, and finally the link between the relationship between the asset and the permit. So when we now insert data points, we will see that it uses the asset ID, the current timestamp, and the value. So now you know that this data point is linked, and you just get a message in the end that you can see that this work permit is connected to this data point. And you get all this in real time now. So I do a few more inserts just to show how it works. And you see it shows up still connected to the same data point. So that's it. If anyone wants to look at the source code, I also have the configuration files for Kafka. That's available in this GitHub repository. So where do you go afterwards, next? Stream processing is actually very difficult to get right. I highly recommend not doing this by yourself, writing your own stream processing code. Try to use some of the established open source projects out there, because like Apache Beam, which I have mentioned here, is built on some scientific papers of how to do stream processing as correctly as possible. And Beam, the application you build in Beam, you run it on Apache Flink. So it's like this very good ecosystem for handling events. One of the most challenging things when it comes to data stream processing is handling event time versus processing time. And basically it means that when someone clicks on a web page, they click on a link, you capture it, that's the event time. But the time it takes to go from that event time into processing it with, for example, Beam, maybe it does some machine learning on it and stuff like that, it may take a few seconds. And if there's a lot of people clicking at once and overloads the system, you may get a processing time that maybe the event is being processed next hour. So you need some kind of window functions to handle watermarks, to handle how you process this data. So you get the numbers, the repos you're building as accurate as possible. So Apache Beam helps you with that. I highly recommend that, yeah, start with Apache Beam before you try to write it yourself. It's, yeah. So I'm not going to show an example of Apache Beam, as it's that's another big presentation. So yeah, that was it. Thank you.